Hi guys, welcome back. So this is the part 3 of the language detection system. So in this, so in the previous parts we had discussed about data cleaning, importing, cleaning, and so basically we made a data set that is ready to be given as an input to the ML model. So in this we'll be building the ML model. Okay, so the task here is to define a training function, and then inside the function what all we have to do is basically we have to load the dataset, separate the features into x and y, and split the dataset into training and testing. And now we are creating a pipeline, so that is the important thing in this. And then we train the data using the pipeline, and then we execute the training. Okay, that's all. So let's move into the code. So the code says the first one is pandas library, import pandas spd. The second one would be test train split. So this is basically for splitting the dataset into test and train data. The third one is TF-IDF vectorizer. So what is TF-IDF vectorizer? It is term frequency inverse document frequency. So basically, let's say some important words like the, and all are present in each language. So that comes repeatedly. So that makes us easy to identify the language. So basically, it highlights the important words, and it converts the text into numerical format vectorizer. So that is TF-IDF, and then we are importing, that is basically naive based classifier model which you are using. Then we are importing pipeline, and then we are importing job lib, that is for saving the data set, and then importing OS finally. Okay, so now we are creating a function called train and save model. So in this we are giving two inputs, that is model path and data path. So the first one is we are trying if the data can be read. If it is read, then we read it and we remove the empty rows, that is using drop in, we remove the empty things. Now if it is not found, then we found data file not found at whatever get data path we have given. So then after, if the data is found, so everything is done, and then we split into two features, that is x is data for training, y is for testing. Now we label x as text and y as language. So now we are splitting the dataset into x train, x test, y train, y test. So now we're splitting the data set into the test size is 0.20, that is 80% of the data is for training and 20% is for texting. Now random set is 42. So why is random set 42? We need the same data to be trained and tested each time. Each time we train it, we need the same data to be there. We don't need a shuffling. So then we are creating a pipeline. Okay, so what is a pipeline? So pipeline is basically we are creating a flow. So we're automizing the flow, so you need not enter each and every time the values. So in the pipeline we have two things, one is vectorizer, one is classifier. So vectorizer, again it uses TF-IDF vectorizer, and here n-gram range is basically when it has one, it checks for each word. For example, it says Python is a programming language, so it checks for Python is a programming language, so it tests for each and everything. Now 2 is basically Python is a programming language, so 2 words at a time. So it checks for everything, and then it says whatever is repeated, that is important. And then we have classifier. So this is basically it puts the vectorized data into the based classifier model. So now we train the data using pipeline again. We train x train and y train. We train the data. So after training, we evaluate the model. So we find the accuracy of the model. So this is again using pipeline, we're doing this problem. So it defines the accuracy. So now we're saving the train pipeline to the model path. So we are giving the train to the model, so it tests it. So using joblib.dump, we are training after training the pipeline, we are sending it directly to the model path, and then we're returning the accuracy. So now we move to the main function. Here, the input is cleandata.csv and model output 5. So this is the output. And then the model accuracy, we are using the function that is train and save model. We're giving inputs. And now if model accuracy is not none, if it is not 0, then we print training complete, model saved to output file path, and then we print the accuracy of this model is this much. So or else we print, check the error messages above, whatever error message we have printed. Now we save the model with sample input. So what are sample inputs? So we give each one sentence from each of the different languages. So this is English, French, Spanish, Russian, Arabic, Italian, and Dutch. So we're giving all these one sentence from all of the languages for training. Now we are using the prediction. We are making the prediction as to which language what belongs to using the loaded model.predict. We are given the sample inputs. So now we are printing the results. This is the format for printing the results. So I'll just run this code and see. Waiting the model, saving the model to language detection model.joblib. Okay, so training is complete. Okay, so training is complete. The accuracy on the test data is 0.93, that is 93% accuracy. So then this is the predicted language, that is English, French, Spanish, Russian, Arabic, Italian, and Dutch. It is in the proper way. So it is accurately predicting things. So now I'll click on submit. So the question is, so they're checking for two things. One is, did the model achieve 90% of accuracy? And then it creates the model file and loads the data successfully. So both are done. I guess it will work. Okay, so both have worked. So congratulations, you've solved the problem. So that's it for this video. I'll see you again in the next video. So if you want to try this problem, then head to the CodeChef platform right now and give it a try.